Coming to my talk today. It's called Loops on Loops on Loops. My name's Garrett Dawson. I'm a front-end developer at ITERABLES. We're a startup in Boulder that builds a product that helps DevOps teams find resolution of their issues more quickly. I love JavaScript. I'm very much a JavaScript developer. This year has been kind of an exciting year to be a JavaScript developer because we've started to see a lot of new things get introduced to the language, and we've had the opportunity to do a lot of experimentation via things like Babel, transpilers, or Tracer, or whatever it is. So today, I'd like to kind of like step back a bit and revisit some things that maybe we already know, but maybe we don't know as thoroughly as we ought to. We're going to talk about loops. And loops are programming. That's like the core concept in programming. They're fundamental to this thing that we all like to do. Without them, there is no such thing as a program. In order for a programming language to exist, you really only need two things. You need a variable, some construct to store state in a program, and then some construct to do computations over and over. Otherwise, you're just like giving these like pretty finite directions. For a program to be Turing complete, it's got to have the ability to like react to things. So we're going to kind of step back and look at these first principles because they're so fundamental. So we can look at the history of loops in programming, and to do that we need to step back to the first iteration, which would be Ada Lovelace and the analytical engine. Are you guys familiar with the analytical engine? It was a mechanical computer, and Ada Lovelace wrote a letter to someone about how she could imagine using a looping construct with the analytical engine to calculate a certain set of numbers. So that's kind of like the primordial loop in software. But of course, we're like not writing things with mechanical computers anymore. We're writing software with syntaxes, with text editors, and you know, this whole thing has evolved. But you know, like anything that evolves, it's always stepwise. So we can look back at even more primordial software and the mechanics they used for looping. So this here is an algol 60 loop, which for me is very difficult to read. I don't know anything about the language, but I just grabbed this snippet off of Rosetta code to see the for loop that they use. And then continued evolution. Here's a COBOL loop, which I couldn't even fit the entire thing in a slide. So yeah, it's pretty big. You have to be very verbose about what's going on in order to perform that kind of looping operation. But again, like continued evolution, here we get a Visual Basic loop, which it's a little bit more compact, a little more easy to reason about and think about. I don't know Visual Basic, thank God, but yeah. So this is sort of like these historical looping constructs, but it's at least 1995, and you're probably a JavaScript developer at least some of the time. And so let's kind of look at our language that we use when we're writing for the browser and the different looping constructs that we have. So of course, there's this ancient and venerable for loop. This is kind of borrowed from like a C-like syntax. It exists in a lot of different languages, and there's like a lot of comfort to this kind of construct. So what's going on is like you've got something that you'd like to loop over. So I'm just, in my slides calling it loopable. And then you have the looper, the thing that's going to do the loop. And there's a few things that you have to do here. You have to like set up an initial counter to like count the step in the loop. And we do that with that let I equals 0. Quick note, you might notice that I'm using like a few ES 2015 constructs in my slides, such as const and let. Those are just variable assignment in the new version of the language. And then so we have to be like very specific about what we're doing in the loop. We have to say like how you're going to step through, where you're at in the loop, etc., etc. And that's kind of a pain. And then when we're actually in the scope of that loop, we don't even get the item that we're looping over. We just get that counter variable that we can use to like access the thing that we're looping over. So there's this sort of like indirect relationship between performing the loop and the thing that we're performing the loop on. This is probably really obvious to most of us because this is like our first introduction to looping. And realistically, we probably don't even write for loops, hopefully, because they're, terrible. We have to keep track of that state, like I was mentioning before. Additionally, like for loops, like anything in JavaScript, we don't have block scope. We kind of do with like let, but I don't really care. Like we have function scope, and things don't get scoped in for loops, and there's just like inherent problems in that. So the language continues to evolve, and we get to this place where we've got something like a for-in loop, which is a little better. There's definitely improvement here. So here in this slide, we've got the thing that we'd like to loop over, and then the thing that's going to do the looping, which is the for-in. So for-in, we still have to like set up a counter, right? We've got to initialize some piece of state that's going to track where we're at in the loop, and then we give the for loop what we'd like to loop over. So like we have to be a little less specific about what's going on in this loop. It's a little more abstract, a little higher level, and that's always a good thing if we can think less about what we'd if we can think more about what we want to do instead of how we want to do it. But again, like we still just have that counter variable, and that's what we're going to use to like access whatever structure we're looping through. But it turns out for-in loops, they're kind of a bad idea as well, because in JavaScript there's not this like strict distinction between like an array and an object. An array is an object, and for-in works on all enumerable properties of an object. So in this example, same exact array, except I'm just going to like throw some extra property on that array. It's not actually like a component of that array. It's not a member of the array, but the structure, it is an enumerable property now on that structure. And if we use a for-in to loop over that structure, we're going to get some weird results. Like in this case, while I'm stepping through that, I'm going to get this enumerated thing. It's just, kind of nasty. So that's why we avoid for-in. But, ES5 happens, new ideas were introduced to the language, and we got these things called array applicatives. So here we've got the loopable. In this case, again, it's an array. I'm using a lot of array examples because that's sort of our most basic list construct in the language. Objects are also kind of like a list construct, but not really. So that's why I'm using these arrays. So here we've got a for each loop that's going to loop over the array, and again we get to like step back. We don't have to be quite so specific about what's going on in this loop. We just say for each member of this thing, do this other thing. We don't have to track where we're at in the loop or anything like that. And this is really powerful and can be extracted into some other things like map, filter, and reduce. And really, like mapping is sort of this basic thing that I think we need to be really comfortable with. So this, while it is really awesome, it unfortunately only works for arrays. And like I mentioned before, we've got objects in JavaScript, and we've got some other new things coming, and we can't use array applicatives on those things, even though they are this like abstract list type, right? So anyways, let's extract those patterns here. Those things that I was just stepping through, there's the thing that's iterable, right? The list. And there's the thing that's doing the iteration. And we can kind of decompose that whole system into those two pieces. So here, like the iterable here, that's the iterable, and then the loop, that's going to be the iterator. And while this is like pretty obvious, this is something that it didn't occur to like TC39 to actually ratify until recently. So TC39, if you're not familiar, that's the standards body that helps JavaScript as a language evolve. And they kind of like create standards and get browser vendors to adopt those standards. So they've decided to extract this pattern, this thing that's like so obvious, and actually make it like a core fundamental piece of the language. And in doing that, they're able to introduce some new things to the language, because now we don't need to have these like less specific things like for loops, for-in. We can then introduce things like iterators that are a little more formal. So have you guys seen these yet? These are the new iterators in ES 2015. So we've got a for of, we've got a spread operator, and we've got destructuring assignment. And these are what kind of belong to that category of things called iterator. So though there is still the array applicative, there is the for loop, and there's the for-in loop, those don't belong specifically to that class. And what sets these apart as this iterator is that they're really generic. They work with anything that is iterable. So let's explore what those actually are. So here we have a for of loop. And we, so there's an example. I've just created this string here, and I'm going to call it the iterable. I'm going to store it in that variable, use the const keyword, which, if you're writing ES 2015, you should just be using const, unless you specifically need to block scope something with let. And you're going to mutate it or whatever. So, yeah, a string, that might not occur to you initially as something that's iterable, but you can think about a string, you can reason about it as a collection of characters. It's just a list of characters, a list of letters. So though it doesn't look like an array, like that's how I generally think about iterables, is like things that look like arrays. String doesn't look like an array, but stepping back a bit and using my head instead of my eyes, like it's totally a list of things. So that being the case, that means we can use a for of to walk through it, to loop over it. So a for of loop looks a lot like a for in. You use the for keyword, then you've got some kind of counter variable, sort of, and then use the second keyword called of. And the thing to the right of the of is the thing that you're going to be doing iteration on. So what's really cool about for of loops is that instead of just giving us back this counter that we use to access the member of the list, that's actually going to store the member of the list during that iteration of the loop. So for of, I'm just going to console log out the character that I'm currently at in this iterable, and it's just going to be each letter each time. So there's no like array index kind of stuff going on, and that's really nice. It doesn't suffer from the same things that for in suffer from, which would be that property where you can attach some enumerable property to an object and it would also show up in the loop. So these iterators, they sort of like distinguish between properties on objects and properties that you want to be like actually part of the data that's being iterated upon through that loop. So next we've got this spread operator, and this one is really sweet. There's no construct that is really like this in the language before, so this is kind of new. And it might not occur to you at first to think of this as an iterator, but it is. Like, I think when I first saw this, I was introduced to it as a way to like collect arguments or whatever in a function. But it's the reason it's able to do that is because it's an iterator. So in this example, I've got an iterable, which is this array here. And then I'm going to like use the spread operator there to just project that array into a new array. And the way that you do that is you take the variable that's containing that collection, the iterable, and you just ... variable name. And it sort of like explodes it into whatever new structure you want to hold that array projection into. So in this case, I'm just like taking an array and putting it into another array, which that may not seem that interesting, but if you realize that this is really just the map applicative, right? So it's the same kind of thing, but it takes it to a higher level. It's more abstract now. There's more things that we can do with it. And as I mentioned before, another cool thing you can do with the spread operator is that you can accumulate remaining arguments to a function. So here we've got a function definition. Are you guys familiar with fat arrow syntax? Okay, so for those of you that aren't, all it does is it kind of like lets you omit the function keyword. And you just give like the arguments list, fat arrow, and then function body. So in this case, what I'm doing is I'm creating this spread operator for just like all arguments that I pass to the function. I don't know, or I don't need to know how many there are in this instance. And because they come back and they get accumulated into this array, I can just operate on it as if it was an array. So here I'll just for each over it, loop over those arguments without ever having to know how many there are going to be. Kind of neat. And last but not least, as far as iterators are concerned, we've got this thing called destructuring assignment. And again, there's like a bit of a leap here to think of this as like a process by which you loop through things. Okay. But that's really what's going on here. So like in all of these cases, what we're doing is we're just like kind of like pushing that knowledge of like looping into just the semantics of the language. We don't have to track that state or anything. So that's why maybe like there is that leap a little bit, but I think it's definitely worth it. So here, again, just an array. It could be a string. It could be anything iterable. And I'm going to use destructuring to loop over that thing and project it into some new kind of object. In this case, it's going to be an array. So what that means is that I've got the let keyword to just like collect these things, and I've got the bracket notation with the assignment is actually kind of like reversed, right? So here's the thing that's iterable. Here's the thing that is going to be collecting those things as I loop over them. So these are pieces. These are variables that are going to store the piece of the thing that I looped over on that particular iteration. And also, I can use the spread operator in destructuring, so you get to kind of compose these two concepts together. So like in this case, if I only really care about these are pieces and I want to just collect the rest of the things into this, array, I can do that. So if I console log out these, I just get back hello, and then here iterable, because that's this new variable that I'm projecting stuff into with the spread operator, I get this new array back. So it is a little weird because there's the brackets involved, and it's not actually an array, but it's like going through this iterable thing and like projecting stuff. So is that more or less clear? I know it's a little weird. Another thing that's really notable about destructuring in JavaScript is that you can also destructure objects, but I don't know, to me that's not terribly interesting for the moment, so I don't think it's worth talking about in the scope of looping. And then this is something that I'm like really excited about. Anybody ever mess with Haskell? Anything that has comprehensions? I guess Python has comprehensions as well, so. What's that? Yep, anything that's got any kind of comprehension. So this is not coming in ES 2015, but it is coming in ES 2016. So given that we've got this whole like ecosystem of Babel, transpile, and that kind of thing, I think it's worth just starting to introduce these into your code because you can just transpile. So yeah, why not? So what this is basically is a for. So we've got to do some sort of looping, right? But during each iteration of that loop, we get to like transform, right? So this is a lot more like that map that I was describing with array applicatives, but it's more generic. It can work on a lot more kinds of types. So we've got array comprehensions coming, and we've also got generator comprehensions. They look nearly the same. Just note that the parentheses and the square brackets are the only difference. And all that means is it's the types that they'll work on, the things that they'll be able to comprehend. And like I mentioned before, this is kind of far out, so it's liable to change. It's not like this is the official way of doing it. This is like the idea is there, and it'll be in the language at some point. It's something I can't wait for. And if you'd like to kind of mess with it and sort of get a feel for what that actually does in JavaScript, Babel has a REPL on their website where you can go turn on the experimental flag and start messing with stuff like this. So it's kind of worth talking about things that can be iterated upon, right? And while I was coming up with this talk, it was a bit difficult for me to like really figure out which order I should do things in, right? Like, should I do iterators first or iterables first? They're so just like conjoined that like you can't talk about one without the other, but because like I'm talking in time, I have to do one before the other. So yeah, Dust spoke TC39. They've defined this specific protocol called iterator. They've also defined this specific protocol for iterables. And in doing that, they've recognized that some of the things that have existed in the language before, those things now are iterable. They belong to that class of things. And that's sort of like things that you can reason about as collections of things, lists of things. And if they are lists of things and belong to this class, that means that they are consumable by iterators. So all those things that I listed before, those three different things, all these types work with iterators. And those types are string, arrays, sets, maps, and generators. And the generators thing is like, that kind of like threw me at first. It didn't really occur to me at first that that would be iterable, but I'll explain a bit about that later on. And I think it's one of the cooler things coming. So let's just revisit these types. String. So yeah, I'm making a string, putting it into that variable called the iterable, and I'm going to use a for of on it to just get members of the string. So like I showed you on the for of before, it'll just give me back the characters in that string. But because it belongs to that class of iterable, I can also use the spread operator on it. And if I did that in this case, I would get an array of all the characters. Yeah, so anything that is iterable can be passed to an iterator. Arrays, of course, like the primordial list thing in JavaScript, these are definitely iterable. So all the things that we can do with iterators, we can do to arrays. And then there's sets. You guys familiar with sets? Sets are really interesting. They're a new type in JavaScript. So yeah, the set object lets you store unique values of any type, whether primitive values or object references. And sets might, like at first glance, just look like arrays, right? Like you read that, that just reads like an array. But actually, sets are like sets in the same sense that sets are sets in mathematics. Like they're unique things. You can't have duplicate members of a set. So this is what that looks like. So I'll use a constructor with the new keyword and say new set. And it gives me back a set. And then I can start adding members to that set. And it obeys the laws of sets. So here if I say like add is the method that you use to like add a member to a set. I'll end up with a structure that's just containing this list of things. And here if I try to add the same member twice, I won't actually get it back. So I can iterate over that with an iterator because it's an iterable. It's a lot of like just repeating of iterator, iterable and stuff. So yeah, for up over that and I get back 1, 3, 2. So yeah, notably, it's all in the same order that I gave it to the set. And I can use the spread operator, I can destructure it, all those things. Next we've got maps. So maps are objects with simple key value maps. We've already got that, right? We've got plain JavaScript objects. That's what it, like they're just hash tables, right? Well, kind of, except maps guarantee the order of the members that they've, that they're wrapped around. Objects don't do that, and that's why when I was talking, kind of just glossing over objects before, that's why they're not really worth mentioning when talking about iteration, because they don't guarantee the order of their members. Maps do that, and that's pretty sweet. So looks pretty similar to constructing a set. You use the constructor with new, and then you can start passing members to it. These sort of like tupleized things. So it's going to be key of value, and then I can pass it to an iterator and get those things back, and I get this array. I think it's best to like talk about that as like that's a tuple that you get back out of it. And you could use a spread operator to destructure it. Something that's notable about sets and maps both is that when you're constructing them, you can actually pass anything iterable, anything that belongs to that class of iterable, to the constructor, and it gives you back that thing projected into that new type. So if I gave new map a string, say, my map would start out, well, not a map, but a set. Okay, if I did that with a set, I would just get back this list of all the characters, and I could continue to work with that list of characters however I decided to. And finally, we arrive at generators. So generators are functions which can be exited and later re-entered. Their context, or the variable bindings inside of them, will be saved across reentrances. So I remember hearing about generators, and I was kind of like, well, that's pretty cool, but I will never use that because it sounds crazy. Like, what is the point of a function that gives me something back different every time? Like, I'm all on board with like purity. I love thinking about things functionally. So like, this just seems like a bad idea to me. But I think I was thinking about it the wrong way, because really what generators are their lists. They're just asynchronous lists. So here's a generator. I'm just going to put it into this variable called maker, and generators are just this function keyword with an asterisk right afterwards. And then inside the body of the generator, you use the keyword yield to say, like, this is the first iteration, this is the second iteration, this is the third. So in this case, we've got this finite list where I'll get 1, 2, 3 back each time I step through that generator. So we'll call the generator and store the generator it gives us back into this constant called the iterable, and then we can start stepping through it using this next keyword, which that may look a little bit weird, but I'll just like explain that a bit more later on. So what's interesting about this too is that like that first step, it just gives us back that first member of this asynchronous list. And then it gives me the second member the next time I call next. So it's not like I'm going to be going back to the top and like having to keep track of any kind of state. Like generators know about their own state. They know where they're at in their iteration. So again, like getting far away from for loops. We're trying to get away from like tracking how we're looping and instead track like what we're looping through and why. So here's another generator. Looks pretty much like the same, has the same effect, but I'm not using multiple yield keywords. Instead, I'm using a while loop, which is contained inside the generator. And something worth mentioning about while is that while is not really like equivalent to for the purpose of, I don't know, it's weird. Whiles are not like for, they don't really belong in the same discussion. They're just like not iterators. But here we're gonna like do some kind of loop, right? And each time we do the loop, we're gonna get to the bottom and go back to the top. So what we end up with here is that we have a generator that when we actually like call it, it's just gonna yield back that value stepwise. It's not gonna just like run away with that while loop. It's gonna wait for us to ask for things. So it's like a while loop where we've been able to control it. So in this case, because I have this finite list stored in the generator, it's an iterable. I can do anything with an iterable well, I can pass any iterable to an iterator. So in this case, I'll just pass into the spread operator, get an array back of the things that are yielded back by that generator. So yeah, like you'll notice in this one, I used the next keyword to step through that generator. In this case, like it's an iterable, so I'll just use the spread operator to do basically the same thing. So here's another really weird property of generators. Generators are sort of like push-pull. They don't just like yield back values to you. You can push values into them, right? So if you want to have a list that you just like go through stepwise, but you don't necessarily know what each component of the list is going to be, you can construct your generators like this. So here we've got this yield keyword, and if we take that yield keyword and we store it in a variable, that yield is going to contain whatever we use next to like push back into it. That's kind of like a tongue twister, right? Like it's sort of hard to describe, but what that means is that if I've got this maker function here, this maker generator, and I call next, so I'm going to say this is just going to echo things, right? So echo next, and instead of just calling next with nothing, I'm going to call it with this 1. And what I'm going to get back is this null value, right? Or not null, I'm going to get 1 back because it's going to yield back to me whatever I pushed into it. Same here, it's going to say, okay, let second yield first. So if I do this, I'm going to get 500 back. So I just like built this weird echo function just for, you know, just to describe what's actually happening there. I know it's like weird, but hopefully like this is getting some of your gears turning. Like there's lots of weird things that we can model this way, right? It's pretty interesting. So I keep mentioning iterable, iterator. That's like part of my talk. That's the title of the talk, I guess. And what I would like to propose is that we sort of elevate our discussion of looping constructs into iterables. Let's just like think about iterables instead of think about how we're going to do these loops. And we sort of like lift our discussion into this world of like type class, right? In a sense, I know JavaScript's not statically typed or anything like that, but like we can pretend. And we can pretend if we talk about it that way. So yeah, think in iterables. So it's an iterable if you can consume it with an iterator and vice versa. So we then end up with these constructs that are like a bit more generic, right? We don't have to be so specific about like the semantics of how to do this loop. We just say like we've got this generic thing that works on things that you can step through that are lists. And when TC39 was talking about that, they decided to really codify this into the language, and they've decided to call it a protocol. So we abstract this idea into a protocol, aka an interface. Even though it's not really appropriate, I'm just going to talk about it as a type class, because I'm, because I can. So what does that mean exactly? We talked about these built-in iterators. We talked about these built-in iterables. How about iterators and iterables that you come up with yourself? Well, they've given us this ability via protocols. And that's, I think, one of the most exciting things about this. So first, let's start by talking about what an iterator protocol actually is. So it's an object if it knows how to access items from a collection one at a time while keeping track of its current state within that sequence. So kind of like a for-in loop, kind of like a for loop, those sorts of things. But you're able to like hammer down like specific types basically using something like a protocol. So all this does is it describes like how you're going to do the loop. And that next keyword that you saw with the generator, I know I kind of like stumbled and mumbled through that. Sorry about that. But that next keyword, that's why generators fall into both categories. Generators are both an iterable and they're an iterator. Weird. So what does that look like? Like, let's make an iterator, just so I can describe this to you. And I'm going to make an iterator for a linked list. Are you guys familiar with linked lists? I wasn't too familiar with it. You know, I learned programming via JavaScript, and it wasn't until I started looking at other languages that I became familiar with it. All a linked list is basically, you can think of it as an array, except that each member of the array, of the list, knows all the rest of its members. It knows how to get to the next thing. So that might look in JavaScript sort of like this, where you've got like the value of the member. So here it's 1, and then you've got all the rest of the members. So it's this sort of recursive structure, right? Pretty sweet, pretty worthless in JavaScript, honestly, because we do have arrays. But I think it's worth looking at things like this. So I've got this bit.ly link up here. I was going to try to pull up my terminal and show you guys what this code looks like. I'm going to do that, but I think it might be a bit difficult to read. So if you do want to look at this a bit more clearly, you can pull it up on your phone at this link. Oh, cool. Highlights purple. Yeah. All right, so that's what I'm going to do. How do you computer? Okay, so let's see. Whoa. Okay, so here's our linked list constructor. It's not too interesting, but if you're, you know, if you're wondering how we like would add members into that linked list, it's just via this this add function here, this add method, you know, whatever. And it just is recursive. It's going to say like, okay, if you've reached a null and you're like accepting some new member, just add it to the end. But we need an iterator to actually like walk through that and get values out. So that's the whole idea of this iterator protocol. I don't want to have to like say how to do this every time. I just want to make up this structure that knows how to walk a structure like that. And I've done that by making this linked list iterator. So as that spec said before, all an iterator is an object that has a next method that knows how to walk through the structure that you pass to it. So what this is going to do is it's going to create this index, and if the current index is null, it's going to give me back this this done property, right? This object. Really, it should be like a tuple with a value of null. I think that's the right way to think about that. But otherwise, it's just going to give me back a done false and the value of the member that I'm currently at. So it satisfies those things that we need from an iterator. It says where we're at in the list, in the actual loop, and the thing that's in the list that we want to get out. And then it yields it back to us in this object. So what is that? So down here, I'm going to make a list, and I'm going to add some values to it. Kind of looks like sets, you know. This is a really bad linked list constructor because there's a lot of other things that should be there, but you know, for this purpose, it works. So yeah, let's push some values into it, and then let's console log out that list, which, let's see. Where am I? Node index. So it gives us back, like this is what that list would look like if I added all those values into it, right? So it's just that like recursive structure. But because we've made an iterator for it, we can say how to actually walk through. So we'll take our iterator, pass the thing through that we'd like to actually iterate upon, and we get this like iterator object, right? So if we step through this now, I'll just use console log so that you can, you know, see what's going on here. Is that real hard to see? Maybe decent, good enough. So you can see here, we're going to like step through this, and at each step, we're going to do a console log. So we say iter next because that's the variable that we've stored our iterator in. We get back the value and the fact that we're not actually done with looping through our structure, right? What's up? Oh, you can't do anything in parallel in JavaScript. It's single-threaded. Yeah. Totally, totally. There's actually like, yeah. Yeah. It's not, so like when you step, these are lazy basically. So it's going to like not yield a value back to you until you ask for it, but it is going to be synchronous, right? So you're going to say like, give me that thing back. It's going to be as soon as you ask for it. You know, if that makes no, it would like if you needed to do something with what next comes back with, it would block unless you wanted to like, you know, like let's say you wanted to return a promise. Like we've got other constructs for encapsulating asynchronous behavior, right? Generators would be one of them, but in this case, like there's nothing asynchronous happening, so you know, we're gonna say next, next, next. Interestingly, there is like an await keyword that people are proposing adding to the language that would, yeah, exactly, totally. Yeah, yeah. We can kind of do that already with generators, but I don't know. As a community, let's figure out what that actually looks like. So anyways, like, yeah, console log, get the next iteration of the loop, and it's going to wait for me to ask for next again in order to get, like, to do that next walk, right? So, yeah, 1, 2, 3, 4, and then it's going to tell me at the end, it's just going to terminate, say, like, you reached the end of the list. Cool. Okay. So if you can make an iterator, you can probably make an iterable, right? And that's like a little more interesting to me because you can encapsulate the iteration behavior in the structure that you'd actually like to walk through. And that's what we call the iterable protocol. And it's fairly straightforward. It's just this symbol iterator. Are you guys familiar with symbols yet? Symbols are a new type in JavaScript too that's like guaranteed to not be duplicates. So it's basically a string, but it's a string that can only ever happen once. It's kind of really cool. But anyways, yeah, the iterable protocol allows JavaScript objects to define or customize their iteration behavior, such as what values are looped over in a for-of construct. So you can create some crazy structure, it can be whatever you want, and you can define how it actually gets consumed by iterators. That's awesome. So, yeah, I'm going to do that. I'm going to do a linked list again, except that this time I'm going to define its iteration behavior in the object itself. Instead of like creating some custom thing, it's like, okay, you're probably expecting a linked list, and if you are, this is how you should walk through it. I can just attach that to my actual constructor. So here, all you need to do that is use this symbol iterator property. And it's got to be in brackets like this. And you just return a function that returns an object that says, like, here's how you go through this. So next, how are we going to do that? And this is like very much the thing that I had before for walking through that, that linked list. The only thing that's different is that I'm going to be referring to that structure via the this keyword. Probably. I thought I did that. Oh yeah, here it is. Instead of like, hey, the thing that you passed to me, that's what I want to walk through, it's just going to be this because it's kind of unavoidable. I hate doing stuff like that, but so yeah, we'll actually make a list, push some values into it, and if we want to get that iterator object back out of it, we're going to actually have to access the iterator via bracket symbol iterator, and then call the iterator, which gives us back that object that we can then next through, right? No problem. So let's see. I need to actually get that in here. JS looks pretty much the same as it did before. But what's really cool about attaching this kind of behavior to the object itself is that then we can think about the object as something that can be passed directly to those built-in iterators. So here I'm going to just use a for of iterator over that, right? I'm just going to for of over it, and because it's iterable, I define the protocol, it's going to behave exactly the way that I want it to, exactly the way that I'm expecting it to. And same goes for the spread operator. So here I can take that linked list and just project it into an array. Because it's JavaScript and we don't really want linked lists. So let's go back here. Okay, so is that clear? Does that make sense? Protocols. All right. Oh, did I not? Okay, whoops. Yeah, there's the bit.ly link if you want to look at that code snippet. Yeah. Okay, so another cool thing that we can do is we can start to use things like generators to build lazy lists or possibly infinite lists. This is pretty slick. If you want to follow along with the code, other than on this screen, here's the bit.ly link. So let's look at what that is. Oh my God, I don't know how to drive this thing. So, infinities. Can you guys see that even a little bit? Is that, I can't zoom. Oh, there we go. Yeah. Okay. So like I mentioned before, generators aren't just these like, you know, schedulers or whatever. What we can actually use them to like model lists of an unknown length, infinite lists, which otherwise known as a lazy list, right? Like in computers, like we've got finite hardware. We can't actually do infinity, but we can pretend. And in order to do that, you have to have these structures like generators. So here I'm going to make a generator, and here I'm going to make a generator, and then later on I'm going to zip those lists together. And both of these generators are infinitely large. The reason that they're infinitely large is because I've got a while loop in here. So while true, yield me back a number incremented by 1. And then this one is going to say while true, yield me back a number plus 2. So it's all numbers, all counting numbers, and all even counting numbers. So let's actually like instantiate those generators, put them into these variables here. So we've got evens and alls. Then I want to make a generator that zips them together. So while infinite is true, infinite is definitely true, we're going to consume the things that we pass to this generator here, and we're going to like step through it one at a time. So if the first generator is not done and the second generator is not done, then infinite is equal to false, right? And that would mean that we somehow reached the end of infinity. Otherwise, I just want to get back this object that's just a tuple of the two values being zipped together. So what does that look like? So this is what it looks like. And these are infinite. Like I could keep doing this until tomorrow, until the end of time, and we would keep getting values back out of this. Obviously, in like writing programs, we don't actually want to do anything like that, but I think it's worth exploring because there's certain things that fall into that category of things, right? Oh, also, something to note here is that definitely you need to use the next thing to step through these lists, because if you pass them to like for of or the spread operator or try to destructure these, those things need to know the length of the list in order to destructure or like spread them. So yeah, I actually tried this. Like you'll just crash your computer if you do that. Though like conceptually it works, it doesn't work with computers. So let's see. Yeah. So what could be a lazy list that we might actually need instead of just like an infinite number generator? Well, event streams can be infinite, right? We can't like create some structure because we don't know when an event stream is going to end. WebSockets are the same way. You spin up a WebSocket, you don't know when that WebSocket is going to be done sending you data. So anything of an unknown length really works better as a lazy list, a list of potentially infinite size. And so we can capture that kind of behavior in things like generators. This probably sounds a lot like something called observables. Are you guys familiar with observables? Yeah, they're like super sick. RxJS, I kind of think we don't actually need RxJS though, because we can just use generators and capture that same behavior in the core of the language. So yeah, thank you for coming to my talk today. It's about iterables and iterators. Get the joke? It's the first slide. All right, yeah, that's it.